this product rule then, used to differentiate two functions multiplied together. And if you can do basic differentiation of a common function, it's very straightforward. All you've got to do is remember the rule. Let me show you how it works and also when it applies. First of all, it applies when we've got two functions multiplied together, as it says here. And how do you know I've got two functions multiplied together? It's if the variable, in this case it's x, appears more than once. So I've got 3x squared, that's one function. And I've got another function, sine 2x. And they're multiplied together. This dot here means multiply. So I've got two functions multiplied together. If I have something like 3x squared times 5x, well then I'd simplify that, collect like terms and call that 15x to the 4. So if x appears more than once, you try and tidy it up and then differentiate it. But if you can't, you've got two separate functions like this, a sine function and a normal x squared function. You can't combine them, so I have to use this product rule. What I do is I let the first function equal u, so you could put a bracket round it and call it u, and the second function v. So I just split it into two parts, so therefore y equals u times v. And then the product rule says this, and it looks quite complicated when you see it. It says that the differential dy by dx is u, which is the first bit, look, multiplied by the differential of v, plus v multiplied by the differential of u. And that's the product rule. And in words, it's worth thinking of it like this. To differentiate two functions that are multiplied together, it's the first function multiplied by the differential of the second function plus the second function multiplied by the differential of the first function. And that's all there is to it. So all you've got to do is be able to differentiate, which you've been practicing, and then you can do it. So let's apply the product rule to this example. So to do it, there's a couple of ways to set it out. The second way is by far the quickest way, but I wouldn't recommend you use that method until you're happy with it. Okay, the most correct way to do it, or the way that's going to lead to least errors, is to set it out properly like this. So I'm going to say u equals the first part, and then I differentiate that. So I write down what u is 3x squared, and I differentiate u with respect to x. In this case, x is a variable, it doesn't have to be, so du by dx, using our table of differentials, bring the power down, take 1 off the power, 6x. And then, and how you actually write it down is up to you, but I would go next to it, I'd say, okay, now what's v? v is sine 2x, so now I'm going to differentiate that, dv by dx, to get differential of sine is cos, and the 2 comes out to cos 2x. So I've written down what u is and differentiated that, and I've written down what v is and I differentiate that. Then I write down the product rule, which is dy by dx equals u dv by dx plus v du by dx. And then, what does that mean? It means the differential is u, which is the first bit, so it's this, 3x squared, multiplied by the differential of the second function, which is this, plus the second function, which is sine 2x, multiplied by the differential of the first. So I just write it down. dy by dx equals u, which is 3x squared, times the differential of the second function, which is 2 cos 2x, plus the second function, which is sine 2x, multiplied by the differential of the first function, which is 6x. And that's the answer. That is the differential of those two functions multiplied together. However, we wouldn't leave it like this, because I can tidy it up. If we look at the first part, 3 times 2 gives me 6 straight away, so I can call that 6 squared times the cos of 2x. We tend to write trigonometric functions at the end if possible, plus the next bit is 6x times sine 2x. So that's tidied it up a bit. Often we look to try and factorise, because if you look at that, the 6 can come outside a bracket, because 6 is common to both, look, and so is an x. There's an x in both of these, so I could take 6x outside a bracket, leaving, what have I got to times 6x by to get 6x squared times cos 2x, x times cos 2x. What have I got to times 6x by to get 6x times sine 2x, sine 2x. And that would be my solution. dy by dx equals that. The hard part is not getting to this, because that's just apply the product rule. Most people find that the bit that follows it difficult, tidying up. And in an engineering situation, you don't always have to tidy up, but you make an attempt at it, okay? And you're practicing your rules of algebra while you do that. So the more you do it, the easier it becomes, and it's all these things. I did say there was a quicker way to do this, and that's just to remember what the product rule is in words. So with practice, you can do it just by applying the product rule in words, which is the first function. So I would do this. I put my brackets around there so I know what I'm going to call u and what I'm going to call v, and then I just literally write down the answer. So now, therefore, dy by dx equals the first bit, 3x squared, multiplied by the differential of the second bit, 2 cos 2x, plus the second bit, multiplied by the differential of the first bit. You can do that with practice and then again tidy up. It's not always straightforward to do the differential, but often it is. Okay?